Hello everyone, it's Mike Levin, Friday, July 28th, there it is. I'd like to get the Empire State Building in for some strange reason. My dad worked there, I worked there. It's the beginning of many of my commutes and reminds me I'm in New York City. So I'm Mike Levin, SEO in New York City. This morning is Friday, July 28th. It's around 9 a.m. and I'm really starting to get into my coding projects. And let me tell you, these are my coding projects. For the first time in a while, I stepped back and I used my 3 daily metaphors. What plates need to be spun, what's most broken, and where do you get the biggest bang for the buck? To analyze the work in front of me, to figure out what the most logical thing to do next was. And when you define that project, it itself has to be moderated by the 80-20 rule. That is, you tackle the project, so by the time you're about 1/5 into the amount of time that particular problem really should deserve, if you had all the time and the resources in the world to tackle it properly, when you're only less than a quarter of the way there, you should be able to stop working on it and still have accomplished most of the key things you need happening. And so in this way, through a series of attempts at pursuing a similarly aligned but slightly further along goal, because you've already banked some of the work from the prior day, you can do what you need to do much more quickly, with more rapid iteration, adhering to more of a scrap and rebuild model than a build once and modify forever, keeping an installed code base model. Because almost everything you do should be fairly easy, built up in a couple of layers. And each time you pull up and inspect one of those layers, you say, oh, here's how I'm doing, here's how I'm handling that. Let me plug that out, pull that out and plug in some other technique that has different advantages of maybe scaling horizontally or vertically, depending on which is limiting your app. So there's a lot of talk here. I have problems. The coding I'm doing is to fix a situation I made for myself by getting some scheduling going right away. Common issue. You script something up. In this case, it starts out in Jupyter Notebook. I'm happy with it. I move it over to a .py file that I maintain through a terminal login to an Amazon Elastic Computing Cloud instance, or they call it an EC2 instance under AWS. And I have just this one server to work with. I'm a marketing guy. It's like, oh, I need to do a few things. Do you really need it? They give you a server. And of course, they're very interested in whether it's actually used or whether this is just like some marketing script kiddie kicking the tires, which is what I always look like at first to the IT and DevOps departments of places I work. Little do they know, I'm going through in my head that in order to get this script that I threw up real quick under a bash script, under the Cron scheduler, under the Debian style cron.daily, cron.hourly directory configuration, which I'm using because I chose Ubuntu as deliberately, when they gave me the choice, as my base EC2 instance instead of AMI or something like that, because I knew I could rely on not having to mess around with the cron tab, which is the text file that you make these cryptic little things to control periodic and exact scheduling under the built-in Linux scheduler. So Microsoft has a scheduler, it's got a graphical user interface. Unix and Linux have schedulers too, called Cron, and they read a cron tab, and there's a program on all Unix and Linux systems that reads this cron tab and then has jobs always going in the background to make sure that scheduled jobs occur. So you drop some text files into a location. Those text files run on the periodic schedule that that directory is bound to. Cron hourly and cron daily, mostly in my situation. So long story short, I use cron. And there's only a couple things wrong with cron, and that is logging and locking. So when you're scheduling jobs that might try and start every half hour, but once it starts, it could run all day and can't be allowed to double run, you need some sort of locking mechanism that is cross whatever. They say cross process. So that would be separate VM instances potentially of your server, separate EC2 servers. Cross thread is another one. There's a whole bunch of varieties of these, and so locks can be implemented so that they work on a horizontally scaled system, separate physical machines or separate virtual machines. But that's way overkill. All my stuff is going to be located on the same machine, so I can use something like primitive file locks, and that's exactly what I did under Bash. Dropping .lock directories and deleting them when the job was done, all under the control of Unix Bash scripts. And that took care of the identical job not running over itself. And then the other problem of making it all fit, I just didn't do. I linked them up serially, one after another. A long job may run, and then a job that takes not a lot of time or not a lot of work had to wait for the long job to finish. And so if you think about it, with how powerful even these little EC2 servers are, you can take much more advantage of these machines by playing a game of Tetris, dropping long jobs in and letting them run concurrently, dropping short jobs in and putting them one right after another serially, knowing that they'll all get triggered off and not compete for the same resources, while the already occupied resources of the already long-running job still continues happily along. So it is a game of conceptual Tetris. So what was most broke in my system was the fragility of an old school home-brewed cron scheduling job for, what is becoming increasingly important corporate dashboards. I spin up on-the-fly dashboards, just like people who do Tableau or Google Data Studio or any of these other, things that connects to a data source, does some processing, displays output. So, in tackling this problem, so I listened to the podcast. I listened to Michael Kennedy and Brian Ocken and all these other wonderful Python podcasts, and I've internalized a lot of how the process goes when you get to this point. I have one server that was given to me by the DevOps department, which they will make sure is running, but I manage everything on the inside. So I'm given a certain amount of real estate, processor-wise, memory-wise, and I use it. I do it in the old school Linux system admin way and throw up a cron job. More and more work gets piled on this, more scripts to put in the cron serial sequence. I could start to play with concurrency there, but under Bash script, under Unix, there's totally ways to do it, but you're in like really cryptic API lands. Old school eternal knowledge and worth knowing that you can do it that way, but not worth doing the work that way. So, based on the podcast, the gears start turning. I go, if I'm deploying different servers, if I'm doing deployment work, Ansible is the one I've been leaning towards. Product named after a device from a sci-fi story, Ender's Game, that I still remember enough to know when references are being made, although I'm sure Orson Scott Card borrowed the term Ansible from somewhere else that I don't quite know. His stuff is the first place I got that idea, but that's instantaneous communication using, you know, the Einstein named, you know, spooky action at a distance. Some tech to watch for, a possibly in our lifetime tech. I'll have to remind Addy of that. Ansible's instantaneous communication anywhere in the galaxy or universe, if you can just get the other controller over to that point, because you probably had to spooky entangle them while they were near each other, and so you take the radio pieces apart. But I digress. Yeah, 80-20 rule. Ansible, overkill. Celery, distributed job task queue that supports concurrency and all the kinds of timing models of periodic and exact timing that I would like. And our team uses it and knows it. Perfect choice. Oh, the old IT joke. First you have a problem, then you choose fill in the blank, now you have two problems. Celery, I've seen that referred to. Of course, it's used mostly for regular expressions. But it was pretty clear that I did not want to introduce a database, a back-end database, into a picture where I've managed to avoid requiring back-end databases of any sort in all my work so far, except for CSV files, direct store of API calls. So that's file system. That's dropping files on a file system as my database, with pandas to load CSV files back in so easily. And then for final display of a dashboard-like thing, there's Google Sheets. Like, I don't need much else, and I don't want more moving parts in the picture, so no. There's like a Python scheduler that's very popular. I think it's like AT schedule or something, I forget exactly, but it's, you know, the one for the web-based interface for people who want that feeling of a polished scheduler polished scheduler project. But then you need a web server to serve the user interface. All I want to do is drop a script in that allows that Tetris-like artistic arrangement of my job. See? Data master. Given one EC2 instance that I can scale vertically from time to time, I did the little test. I asked for a small one, started to use up capacity. I said, ooh, can I grow? DevOps is like, hey, here you go. And it's such a small line item on their budget that it's in my interest to keep them maintaining my server from a DevOps standpoint, and me maintaining the server from an app development standpoint. However, in this case, with a scheduled task, a lot of that app development work looks a little like DevOps work and sysadmin. So I choose a scheduler, a job task queue that is simple, supports concurrency, supports periodic and exact scheduling, and I make it not require a back-end database. I want it to just run a couple of include files at worst, which are sometimes third-party libraries that you have to do a pip install or a pip unfreeze, whatever it is, to get all your requirements met. The process of doing that under Python is getting systematically slicker and cooler, cleaning up the pip code, changing the underwirings of it to this thing called wheels that supports, you know, multi-platform target precompiled binaries. Things like pipenv from the guy who made requests, which will, you know, package up an exactly reproducible environment ready to run, unlike the pip freeze and pip install, technique, which I've stopped using. I just, I do the pip freeze and then I read it and I trigger off the installations, because maybe there's an apt-get install or something you need to do, or maybe there's a conda install for custom drivers like Psycop G2, the way you connect to a Postgres or Redshift database from Python most frequently. Even things like SQL Alchemy require that. So it's one of those low-level driver things. But anyway, I once again digress. Yeah, so I zeroed in on this one called schedule, pip install schedule. It gives me exactly what I need. It's taking a while to figure it out because it is like Flask. It'll support concurrency if you understand concurrency. If you can use the threading library in Python, they give you just enough to create concurrent, exact, or periodic scheduling. I just then had to layer in file locking, or job locking, if you will, which I pretty much established in my mind was going to be file-based. I just wanted all those crazy conditions of file-based, locking to be handled by smart libraries. So I found one that appears to be used by the highly supported and highly used OpenStack project, which is a whole bunch of projects that allows data centers to be built on Python and a few other languages and open source projects, basically reproducing the rack space business, almost like the Amazon EC2 business, but without quite all the features they give you, but forever more and more, because it's free and open source and it's always growing, and lots of people use this. I think NASA uses it and supports the project for their homegrown data centers. And so there's something called fasteners. That's one of their dependencies, or appears to be. The last update was 2 years ago, but that's not always a bad sign. It may be solid, and all it does is it creates file-based locks that you choose the location and name of. You usually drop them into the Linux or Unix temporary directory, so that every time your machine restarts, it basically clears out your locks and your jobs can restart if the machine got reboot or something. So these are all fairly important considerations. And the APIs it works with is it can use decorators. So any function you write, you can just decorate it with a directive above the function that begins with the @ symbol. And it says whenever you go into that function, use a lock. Whenever you exit, automatically close the lock. If it exits by, keyboard interruption or a kill or any of those other things that can end a task, it will also remove the lock. And it deals at the operating system level to make sure it's using the cryptic nomenclature so that you don't have to. Other ways you use it is you can do open with and name the lock, and as soon as it comes back out from that indent that you use under an open with, the lock is released. That's an API pattern that's used all over Python now, forevermore. Wherever you would have opened and closed something and then had to have used all these tries and finallys and, strange but possible constructs in Python, you just do open with and it wraps it up into all that, clean little API. But it says no matter how I fail and outdent from this indented open with, clean up after me. Close open file locks, whatever. So fasteners uses that. And then finally there's explicit. So you can use a try except. So you can explicitly control when the file locks are being opened and closed and tested for, to avoid running a same job twice. And I like that. It's not as messy as it could be. It doesn't take advantage of the solved problems that certain API patterns provide, like decorators and open with, yay Python. But it is explicit, and explicit without being made to be too long or verbose, such as I am. And that's going to be that together with the schedule package and a few others. I put a package in there, log 0 for color-coded logging instead of print statements all over the place. Once again, thank you, Michael Kennedy and Brian Ocken. And I'm also using a library that takes my input and turns it into ASCII art. So I love me my big ASCII art in the standard font as debug output console text streams at you from your program. All your debug statements, bam, 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 it gets to another function. Poof, a label appears in 2-inch tall letters, red or green or any other color, because I'm using another library to let me switch colors in a standard Unix color terminal window. So big 2-inch high ASCII color letters to show going in and out of certain functions or sections of the program if it's top down. File locks from Fasteners. Fasteners is the one I ended up using. Fasteners. I'll have to get all these library names down, but maybe I'll open source it, but I'm developing it on my employer's time for my employer, so I may have to clear it with them first, and it's a competitive advantage. So what we have here is, I'm a marketing guy who writes code. Fine, here's an EC2 server. Please actually use it or we'll be pissed for giving it to you. That's just very typical DevOps. No one ever says it out loud, but it's a recurring theme. I use it to great effect. However, I fail to scale horizontally or vertically, and know I can do both. I do not want to become my own DevOps person. I want to run more jobs on the servers they gave me. So what I'm going to do is offload all file storage to various possible locations, tables in a SQL server, Amazon S3, data buckets. I got all sorts of choices. That'll offload any data storage overhead I have and get me a lot more capacity out of the server. But then I am going to schedule jobs like I'm playing Tetris. And last piece of the puzzle, by the way, since it's a .py file, like a schedule jobs.py, you need to run that, and you need to run that in a way that if it stops running, it'll run again. So I am using, today's job is to use the supervisor D daemon monitor and relauncher. Bam, bam, bam. Every time the system's rebooted, every time a Python script forces a quit out of the running loop, any time a Linux-based system daemon will identify that and relaunch it and optionally take other actions, I do believe, which I'll look into because I want to always be warned of things going wrong. So notifications and actually switching my current Cron and Bash-based jobs over to this system is my job today, and I'm pretty darn pumped over it. Once again, data master, jack of all trades, a la old school webmaster, been an SEO for a good long while, did some Web 2.0 innovation stuff, which is still out there. Got tired of being in various shallow parts of the industry and various rat race, intense parts of the industry. And finally, settling into the data pulling, combining, shaping, storytelling part of the industry to make recommendations to go and do certain things to create positive feedback loops. Right? Clear enough. I hope so. I hope it doesn't all come out like blah blah. And step one in doing that, what was most broken, is a reliable and efficient and optimized place from which to run scheduled, mostly Python scripts. That back end and power is the monkey in the middle that knits together your deliverables daily. thanks. More on this later as motivation and the limitations of doing proprietary work allow. So far, I think I'm in a pretty good space, but I will modify these things as I go so that my Kung Fu remains the best in the SEO industry. That's kind of my mission, my personal mission here, in the pursuit of the mission of those who I am strongly affiliated with, i.e. my employer. It's Mike Levin, SEO in New York City. Thanks for joining me. Hope to talk to you soon, and don't forget to subscribe.